All right. Regarding to the questions involved in particles of natures of matter or particle natures of matter, I say in a reaction, hydrogen with oxygen reacted to give us water. How many moles of water can be produced from 3 moles of hydrogen? How many moles of water can be produced from 3 moles of hydrogen? All right. In particular, the moles of the mole ratio should be H2 against, because we are dealing with hydrogen here, and hydrogen in question is hydrogen 2. Okay, any hydrogen elements are always 2 in number. So let's see the ratio at which we can generate from this very place. Now look at the reaction. Here we have 2 against 1, because hydrogen against oxygen is 2 against 1. And if I may say, 3 moles of hydrogen produced in this will be giving us hydrogen against hydrogen against water is 2 is to 2, which is equals to 1 is to 1. Are we there? So now each of them has a respected what values. Now how many moles is produced? So we have 3 moles of hydrogen is equals to 3 moles of what? Of water. As simple as that. Since we're working on one against one. Now let's see another question regarding to this. Now let's assume that how many grams of carbon dioxide are produced from the combustions of what? Of 2 moles of propane. Now this is carbon dioxide here. Okay, so they say how many moles of carbon dioxide is in the combustion of in this combustion. Now let's see. If you observe it very well, you will get this is 2 carbon dioxide here elements in what ratio? Propane. So we are reacting this against this, and let's see how it goes. Now if you check properly, you will discover that carbon dioxide here is containing, that was a mistake, this is 3 not 2, to balance the equations. Let's balance the equation. So here we have C3H8 is to CO2. So we have it as 1 is to 3. So if you want to know how many moles will be here, that simply means that if 3 moles are given to us calculatively, we have that C3H8 is equal to 2 multiplying 3. How do we do that? We have that 1 from here against this 1 minus this will be, so 2 of this one, because this value here is the ratio value. So they say 2 moles of this is combusting with this. So if we have 2 moles here, number of moles is 2. So 2 multiplying the number of available reactants, which is number of moles here. So this is the combusting mole and this is the reactive mole. Okay, so multiply this 2 by this, we have what? 6 moles in total, to give us what? To give us CO2. So we then have that C3H8 combusts with 6 moles of what? Carbon dioxide in general. So we can actually get this. This is the number of carbon dioxide. We can actually rectify this by saying molecular weight. Let's check via molecular weight. So if molecular weight of this CO2 is equal to carbon is 12 plus oxygen here is 16 times 2. So sum it together, we have 44 gram per mole. All right. So if the molecular weight of this one is 44 gram per mole, let us determine the number of gram. How do we remove the gram? Through the mole. Look at the number of mole here. So we say gram over mole times what? Mole. So that mole will cancel mole. So how do we do that here? We now say that 644 gram per mole multiply 6 moles. That will give us 264 gram. So that is the number of grams needed for this. How many grams? There are other ways to solve this problem though. There are shorter ways to solve this. Let's see a shorter way to solve this problem. Let's assume that this was not given at all, and then you were told to calculate this, or let's analyze this way. And then we have 3 grams here, CHO8 against 3 CO2. So we have 3 here. This becomes, with these 2 combustion, we have 2 times what? 3 CO2. Okay? So this becomes 6 CO2, which is equal to 6 times 12 plus 16 times 2. These 2 here. And that gives us 6 times 12, 12, that is 44. So multiply this together, you will get 264 grams. As simple as that. So this is another short way of getting this. 264 grams. See? Very, very short. So you can use either the other one or this one to get the same answer. As simple as that.